So this is a quick introductory lesson to, again, the combined gas laws in this case, a different version if you've ever seen it. This is actually the ideal gas equation. And I hope that you all know what this letters mean. P is pressure, V is volume, obviously T is in temperature, and the temperature always has to be in Kelvin, okay? N is the number of moles. So, okay, and then R obviously is the gas constant, and this gas constant is actually shown here. That is always going to be 0.0821 liters times atmosphere over moles times Kelvin. Anytime you have to use R, the units for pressure has to be in ATM. It has to match the units in the gas constant. So the unit for pressure has to be in ATM. The unit for volume has to be in liters. The unit in temperature obviously always has to be in Kelvin. Okay? But if the R is not present, you can use any units for pressure or volume, right? Again, the only thing that is set in stone here in this case is temperature. Temperature always has to be in Kelvin. So what does all of these words mean to you? What this means to say is all you have to do is look at variables in this case. So we have pressure, volume, initial, pressure, volume, final. Okay? If they are on the same in this case the same area, or in this case the same level of the fraction bar. This is the fraction bar. This line that goes in between them is called the fraction bar, obviously, right? What happens is if they're on the same level, like in this case pressure and volume is both in the numerator, there is what we call an inverse relationship. Okay, now please, you cannot compare P1 and P2 over there. You always have to pair them together. What this means to say is that when pressure goes up, okay, pressure goes up, what happens to the volume? Okay, anyone? Okay, so that is called an inverse relationship. Okay, so if I decrease the volume, I increase the pressure. Okay, and vice versa, right? If I increase the pressure, okay, what happens to the volume? The volume will decrease. Okay, now however, having said that, you need to understand that the volume actually impacts pressure. Okay, so if I make something smaller, what happens to the pressure inside in this case the gas particles inside this container? Well, obviously the pressure is going to increase because the space that the gas particles have occupied now becomes smaller. Okay, so that's called an inverse relationship. So there's an inverse relationship between pressure and volume, right? There's an inverse relationship between the number of moles and temperature. So if the number of moles increase, guess what happens to temperature? It's going to increase. Okay, so I hope this makes sense. Now there's also obviously, so that's a relationship when they're on the same side of the fraction bar. What happens when they're on opposite sides of the fraction bar? Like in this case, pressure and temperature, or volume and temperature. Okay, I'm sorry about all of that mess. What happens then is what we call a direct relationship. What that means to say is, okay, if pressure goes up, what happens to temperature? Temperature will go up. Okay, if temperature goes down, what happens to the volume? The volume will go down. So that's called a direct relationship. Direct relationship means they follow each other. One goes down, the other one goes down. Okay, inverse relation means they go opposite ways. If the pressure goes up, then the volume goes down, and vice versa. Okay, so I hope that makes sense. This is actually a good way for you to understand the answers that you actually should be getting. All right, but again, for our purposes, this is again should be sufficient for this week's lecture.